What we are about to discuss now is the reactions of aldehydes and ketones with primary amines. Primary amines attack aldehydes and ketones under specific pH or specific pH medium to give what's called imines. Imines are interesting functional groups where there is a double bond between carbon and nitrogen. Let's draw or write a scheme for this reaction in order to understand what's going on. So this is, for example, an aldehyde. That's an aldehyde. If you react the aldehyde with a primary amine like that, or ammonia, even the simplest amine possible, under pH of 4 to 6, and we will talk about the role of the pH or the acidity medium, if you like, in these reactions and the importance of that. So the aldehyde reacts with a primary amine at pH 4 to 6. What's produced is the corresponding imine. That's an imine product where there is a double bond between carbon and nitrogen. This compound or this functional group is called an imine. That's because there is a carbon-nitrogen double bond. So that's an imine, and the imine is produced when the amine is primary. So a primary amine reacts with an aldehyde or a ketone to give the corresponding imine. The pH is really important here to drive the reaction forward, because remember, these reactions are also reversible, just like the reactions of alcohols with aldehydes and ketones in order to form hemiacetals and acetals. Let's try now to draw a possible or write a possible mechanism for this reaction in order to understand what's going on, and also in order to appreciate the role of the pH or the acidity point in this reaction. So the first step would be reaction of the primary amine. So that's a primary amine with the aldehyde or the ketone. So the nitrogen, which has a lone pair now, attacks carbon of the aldehyde or the ketone in nucleophilic addition step to give this nucleophilic addition product. There is obviously a positive charge now on nitrogen. Now, at this stage, an acid is not really required, okay? Because if we use a strong acid concentration, in other words, if the pH is 1 or 2, if the pH is highly acidic, that will be enough to protonate the amine. If the amine is protonated, the reaction will not be useful for this amine formation reaction. What's going to happen next is that water, being in the medium now, water will come and take off one of these hydrogens. So water will come and take off that hydrogen, and the hydrogen-nitrogen bond will then be broken. As a result, some hydronium ion is actually produced. Okay, so let's write the intermediate so that we understand what's going on. So we have now taken off one of these hydrogens or nitrogen, plus we have generated some concentration, if you like, of the hydronium ion. So we have this alkoxide intermediate, plus we have the hydronium ion here, which has been generated along with that intermediate. So what's going to happen next is that alkoxide will now get protonated by the formed hydronium ion in the first step. So what we get is this. Now, this is an important intermediate. It's actually similar to the hemiacetal that we have seen before when alcohols react with aldehydes and ketones. So this intermediate is called hemiaminal. So this intermediate is a hemiaminal intermediate as opposed to hemiacetal. If you notice, that carbon has an OH group and an amino group. If carbon has an OH group and an amino group, it's called hemiaminal. Now, in order to drive the reaction forward, in order to go from the hemiaminal to the final imine step, some acid concentration is really required, and that acid is required in order to convert that OH into H2O, which means a beta leaving group, to be expelled by the lone pair on nitrogen. So for that, some acid concentration is really required, and that's why the pH should be 4 to 6. Remember, if pH is 1 or 2, this will induce or will promote, if you like, protonation of the primary amine, which will not be useful for this imine formation reaction. At the hemiaminal stage, some acid is really required to protonate that OH, otherwise the reaction will not go forward. In other words, if the pH is very high, like 12, 13, or 14, or if the medium is basic, protonation of that OH will not be possible, and therefore formation of the imine will not be possible either. So some acid is really required here. That's why the pH should be between 4 and 6. So we can draw the hydronium ion again. So the OH will get protonated at this stage. The hemiaminal, or the OH in the hemiaminal, will get protonated by this well-controlled acid concentration, by well-controlled acid concentration, as indicated by the strict pH of 4 to 6. If that protonation takes place, we get this intermediate now, where we have now OH2 and a positive charge on oxygen. Now this sets the stage for the removal of water, if you like, or elimination of water, because now water is an excellent leaving group as a result of this protonation of the hemiaminal by the hydronium ion. In order to remove water, we can actually use the lone pair on that nitrogen to expel it, to expel water. So we take an arrow from the lone pair on nitrogen, and then we make a double bond between nitrogen and carbon, and this therefore expels water. So this what would be the driving force for the elimination of water, is the lone pair on nitrogen. Now what we get is this intermediate, which already has a carbon nitrogen double bond. So we get that intermediate plus, of course, water, which is eliminated in this step. This is not quite the final imine product. So what's going to happen is that the water that's produced will now come and take off that hydrogen to give the final imine product. So we can draw water here. So water will now come and take off this hydrogen. So we can indicate that with an arrow. We can indicate the electron movement with that arrow. The hydrogen-nitrogen bond will now be broken, releasing electrons to the positively charged nitrogen. So what we get is actually now the final imine product with regeneration of the acid catalyst. Now, to wrap this up, to summarize what we have talked about in this mechanism or in this reaction of aldehydes and ketones in general with primary amines, at a specific pH medium is that aldehydes or ketones react with the primary amines at pH 4 to 6 to give the corresponding imines. The pH is very, very important. If the pH is low, in other words, if the medium is highly acidic, that will not be useful for this imine formation reaction, because if the medium is acidic, this means that the amine will actually get protonated and the reaction goes nowhere with respect to the imine formation reaction. Now, at the hemiaminal intermediate, some acid concentration is really, really important, and that's to protonate the OH group in order to convert it into a much better leaving group, which is water, which will be expelled in the subsequent step. And finally, the carbon-nitrogen double bond is formed, or the imine final product is actually formed.